I watched a Harvard professor lose his mind trying to explain fractions to a pre-med student. It changed how I see intelligence forever. A third is bigger than a half because 3 is bigger than 2, she insisted confidently. That moment in echo calculus pernt, watching a brilliant professor completely unravel while trying to explain elementary fractions to a pre-med student with a 4.0 Nepalade pernt taught me more about education than my entire teaching degree. I was a teaching assistant in Professor Harrington's calculus class at one of America's most prestigious universities. The kind of institution where acceptance letters are framed and parents casually drop the school name at dinner parties. The kind where you assume every student is, at minimum, proficient in basic math. You would be wrong. It started innocently enough. Professor Harrington was explaining partial derivatives when Alexis, Hart, a junior with perfect hair and a spotless academic record, Parton raised her hand. I don't understand why we're using fractions here instead of decimals, she said. The professor paused, likely assuming this was a question about notation preference. Well, fractions are often clearer for these concepts, but we could certainly use decimal equivalents if you prefer. But fractions are confusing, Alexis continued, like, which is bigger, 1/2 or 1/3? The classroom fell silent. 2 students exchanged glances, wondering if this was some kind of joke. Professor Harrington's chalk hovered mid-equation. 1/2 is larger, he said carefully. 1/2 is 0.5, while 1/3 is approximately 0.33. Alexis shook her head confidently. That doesn't make sense. 3 is bigger than 2, so a third should be bigger than a half. What followed was the most extraordinary 30 minutes of my academic career. Professor Harrington Pert, who had published groundbreaking papers on complex analysis, abandoned his lesson plan to explain fractions to a college junior. First, he drew 2 identical circles on the board, dividing one into halves and the other into thirds. Which piece is larger? He asked, pointing to a half versus a third. The third, Alexis insisted. He tried pizza analogies, he tried dollar bill examples, he grabbed a sheet of paper, tore it precisely in half, then took another and tore it into thirds. He held up the pieces side by side. Which piece is physically larger? He asked, his voice straining with forced patience. Alexis pointed to the third again. The professor's legendary composure began to crack. Alexis, forget the names, just look at the actual size of these pieces of paper. Which one is bigger? A third, she repeated as several students began to nervously laugh. Professor Harrington placed both pieces on her desk. Pick up the larger piece. She picked up the third? That's the smaller piece, he said. No, it's a third. Third is bigger than half because 3 is bigger than 2. The professor's face went through an extraordinary transformation. Pure confusion, disbelief, frustration, and finally a kind of existential surrender I've never seen before or since. He walked silently to the window, stared out for a full minute, then turned back to the class. Let's take a 5-minute break, he said quietly before walking out the door in the hallway. I found him staring blankly at a water fountain. 27 years of teaching, he murmured. I've explained quantum mechanics to literature majors. I once helped a student understand Concessiondel's incompleteness, the Horem over lunch. But this I cannot do. Alexis graduated with honors the following year and was accepted to 3 medical schools. I sometimes lie awake wondering if she's now a surgeon somewhere, confidently telling patients she's removing a third of a tumor because it's more than removing half. This experience fundamentally changed how I understand intelligence. We assume it's linear, that someone smart in one area must grasp simpler concepts. But the human mind is more like Swiss cheese with inexplicable holes in unexpected places. Somewhere in America, there's a doctor who graduated near the top of her class, yet believes a third is larger than a half, and somewhere, here is a brilliant mathematician who can't remember to take out the trash or struggles to read social cues. Intelligence isn't a ladder we climb uniformly. It's a constellation of islands, some connected, some mysteriously isolated, and sometimes the most valuable lesson in education isn't what we learn, but realizing the strange, beautiful complexity of how we fail to learn.